this training will be including 3 sections. Today's one, and this Thursday, same time, 1 hour. And then the 25th. 25th is next Friday. What is the first section? Today we are going to give a big picture. What is the architecture of the TACC supercomputers? What is the file structure? What is the software structure? And how the resources available for us. And then this section we left 10 minutes. So give you the chance to register in the TACC so you can create your own account. After you create the account, you need to send your account information, account name, your email address to me, and then I add you into the Lamar available resources, what the term they call allocation. And then next time, the 17th, so we can directly log into it to play around, to look at what kind of software, what you are interested in, and how do you create AI environment, what the package available, and how to use the system based on what you need. Okay, that is our plan. First of all, what is the TACC? TACC says Advanced Computing Center. This is the Wikipedia. They introduced Texas Advanced Computing Center. It's located UT Austin. What I want you to know is here, which is founded in 2001. This time I contact with there and try to request the resources they are approved. So I'm the basically the one project to manage the resources. So I invite everyone in the Lamar can jump into use the resources. You do not need to apply yourself, write proposal to create account and to manage it. So to unload your burden, you directly use it. The one term I would like everyone know is here. TACC is one of the center of the computational excellency in the United States through National Science Foundation, Extreme Science and Engineering Discovery Environment, XSEDE. So you basically you did know this term. In the future, if you need something, this center does not have, somewhere in the other universities in the United States, particular university, they have some kind of special software available, and then I can use our available resources to make exchange, and then you can access that. So I would like you to know this term, extreme science engineer discovery environment. This is association or union that's all funded by National Science Foundation. Initially, they called TACC. So this is something I would like to give you a brief idea. The TACC, they designed the supercomputer. We know they has powerful system. Why we are here? Why we have this factor? Why we need this one? Because nowadays, a lot of research related to AI, machine learning, big data, and we need computation power. But unfortunately, Lamar does not have that kind of. Dr. John, he has a supercomputer previously funded by National Science Foundation. We called RED in our IT data center. They have the 40 nodes. It is running for 6, 7, 8 years. And right now, Lamar does not have funding to support the license fee. HPC was expired. We does not have that resources. If you want to do the GPU, AI, machine learning, basically Lamar has no. Only last year, we used our department fund to buy one machine, 2 GPUs. But it is cost like $39,000 for one machine. If only one student to do project, student's project, that machine going to hang on for running weeks. If one student submit the job, my machine is going to use 100%. No other users can use it. So this is the situation we are facing. But luckily, TACC, they have these resources available for the researchers, especially available for us. We want to encourage everyone to take this opportunity to use it. At least you log in to look at what is available. And if you write a grant, you can list here. We have these resources available. If you want to do computation, there has world level of the computation power available for you. Okay, so let's look at what's the system available over there. There are multiple systems. What we're talking about system means supercomputer. The system equal to supercomputer. Supercomputer, what we means high performance computer that is not one machine. It's a thousands of machines put together to run in one system. The Frontier, that is the fast academic supercomputer in the world. This is the fast. But this one is not, in my proposal, I'm not applying this one. There is another one, AI focus on the supercomputer, that's bridging Frontier, the current National Science Foundation supported. This is the one we are available, STEPI 3. This is the newest one. This is the latest one. Even right now, it does not fully configured yet. Some resources still, they are doing the configuration. It's going to be available very soon. So we have access for this STEPI 3. That is the newest resources. And Lone Star 6. Lone Star 6, this is very unique, also very new. This is what they call supporting Texas researchers in providing simulation, data analysis, visualization, and AI machine learning. Here has several others. Also, they have the storage. These 3 storage is also available for us. The first one, Coral, that is the storage and data management resources designed and optimized to support large-scale collections and collaboration research environment. This is high-speed, high available, large range. Range is a long-term data archive environment designed for the implement and supported for provide storage for data set. This is for the long term. If your research data, you want to make sure you don't lose it, you can upload into here. They are going to have tape drive to tape backup and make sure you are not going to lose any of the data. So these 2 is available for us, and they certainly have the quota, certain space available for us. Stockyard, this is also storage that is based on the project. It's not for the individual. If the project, for example, Lamar, I have applied this project, we have certain space we shared within all the Lamar. If you want to share your data, you can put here. Others can upload, download it. Okay. Also, they has the system is you see this is one they called one of the highest resolution display in the world. This is for the high resolution visualization display system. So this one you need to on-site. Here is a router that is customized engineer matrix display. This is special purpose use. Basically, we have 2 systems. These 2 systems for computation. This one is majorly CPU. This one is head CPU, also majorly for the AI machine learning that is available for us. Okay. So 2 computation system, 2 storage that is available for Lamar. The picture here you see is STEPI 2. It's actually currently is a STEPI 3. Lone Star 6. The bottom here, that is what they call the data storage. It's Cora for the high-speed data connection. This one is for the archive. They call it range. Okay. What is the structure? You see here, everyone, you are going to go to the portal, the TACC portal, to apply count. And then only one count. Your one count, you can access all this system. One count, username, password. This one, STEPI 3, that is available for us for the high performance computing, basically the CPU. But within this CPU, there are several architecture, several Intel processor has different number of the nodes. I'm going to introduce what exactly the difference. Based on their architecture, you can select which nodes you are going to use. This one is hybrid, so they also has a GPU available. The GPU is not NVIDIA. This GPU is Intel GPU, but they also has their software package. From your user-wise, I don't think it matters. You just use the Jupyter notebook to program. I tested this one. The GPU is actually not available right now. I sent email, asked them. They said they are still working on it. It's going to available very soon. The Lone Star 6. Lone Star 6, that is majorly for the GPU. The major work is the simulation, data analysis, visualization, machine learning. Okay, but you know nowadays a lot of research projects use these kind of resources. You probably need to waiting for the queue. I'm going to introduce how you look at when, where, how many nodes you are going to use. They has real time tell you the utilization, how many nodes available, how many job is waiting in the queue, and then you can, based on your job, to select which resources. Here they have a special term called queue, or they call it partition, means what kind of architecture. For example, here the GPU nodes, they have special architecture. If you want to use that kind of architecture, you select the partition or select the queue to use it. Here, the storage. This is high reliability, high performance storage. I'm going to show slides how much the space, probably it's like a 5 terabyte or something. The archive, you can also, all the same username, but this is individual system, individual supercomputer. So when you access it, for example, if you want to SSH lonestar.tac.ut.edu, that is, you directly access that supercomputer. Within that supercomputer, you have your home directory, you have your storage, you have your scratch space. Okay, this is the big picture over there. But before we really began to use, we be familiar with some terminologies. The supercomputer, they have their set of terminology. So you have to have a picture. This is the supercomputer. It's not one machine. It's not like you do in your own computer. It's thousands of the machines. When you log into your home directory, that is the place you save your data, save your program, but you are not going to run your program from your home. You need to find a particular partition, particular architecture. You get into there, and then run your job in the computing nodes. So if you need special software, you can imagine there are thousands of the machines. You cannot install all the thousands of machines. So you have to install in the one particular location. And that particular location is under your working directory. And then when you run the program, you need to get into particular architecture partition and then to run your program. Okay, so it's different from your own computer. If you need something, you have to use their system. You just cannot to download software, install. Cannot do it. You can install into your home directory or your workspace. Most of the time, they don't care. So if you install the whatever the package software, if you can put into your home directory, it's fine. You have like a 15 gigabyte, 1 terabyte workspace. We need to know how they manage their system. They based on the project. They based on the allocation. They based on the system. Okay, and also they are going to count your service unit SU. It is how many hours they are going to count. Certainly, it's free for any of this. Currently, we have 6,000 hours. If we still need more, I can apply to increase the hours. So, projects. Request to use TACC computational resources is based on the project. Everything is based on project. The charge going to check on the project. The project is everyone can apply. The professors, if you want to dedicate your project, write proposal to submit over there, and then you're going to have your allocation. You have your own hours. If you don't want to do that, if your hours is not really that huge, I have a project here, so I can manage users, so you do not need to worry about that. Researchers submit proposal to apply project. After project approved, allocation will be assigned to the project. Allocation means certain hours for certain supercomputers. Okay, there are so many supercomputers. They need to know which one you are going to use in which. You see here, this is the when we apply, we just gave a name, and then you probably need to know this code. This code is a project code. Whenever you run your project, you need to give the project code. Then they are going to charge our hours within every program you run. After you got the count, you are going to have this similar screen. You know what is your project, how many hours, and what is resources available for you. For example, here we have 2 supercomputers. And if you have any question, you can submit ticket. You click ticket. If you have the generate error, you don't know how to fix it, you click there, generate ticket. You copy the error message, submit over there. The technical support, they are going to answer your question. So this is a very good supporting system. They have dedicated the professionals over there. Here, the status, you are going to know. You see here, the Lone Star, 95% is utilized. And then there has 500 job is waiting in the queue. You don't want to do that. You probably can use our Service 3. And then this is 78%. Although only have 8 jobs, maybe it's just 1 or 2 minutes is available for you. So you can find what is the best. I have the slides, the details. You can looking for the partitions, the query, and then how many nodes available. And then you find, for example, if your program is not really parallel programming, you really don't need 1,000 computers simultaneously. You only need 1 or 2 computers. You can find the big memory nodes, and then the smaller partition. I only request 1 computer. Probably you are going to get very quick. Okay. This is the interface you are going to get there. And then what is the allocation? Allocation is time granted on the special supercomputer. This is associated with project. A single project can have multiple allocations. Allocation means the supercomputers, how many hours we can use. So we know in the Lamar, right now we have 2 supercomputers. We have 6,000 hours. User count must be added into allocation in order to log in. So that is why today, going to the end of the 10 minutes, everyone apply count. Then you send me email. I'm going to add you into our allocation. And then make sure next time, this Thursday, 17th, everyone can log in. Okay, so this is the allocation. The portal, when you log in, so you know the project code, you know how many hours we have, how much used, what is expiration date. Right now, I add everyone into this project. The next year, we have another one, total how many storage, how many the hours, all informations you can monitor at here. Okay. Service units. Service units is used for there to counting how much hours this project used. So basically is they are billing count that 6,000 hours by this way. How many nodes you are going to use and how many jobs used in the wall clock. The wall clock is computer science the terminology. It's basically your program start and then your program stopped. During these hours, they count as a wall clock. So basically, how many hours your job running, and then they have the charge rate. Some nodes, they have a little bit higher the charge rate. Some nodes have the lower charge rate. Okay, but for your user, you don't need to worry about it. Whatever you need to use, just go ahead to use. And I'm the person to dealing with there. I need more to ask there, give us more. Okay, so the current is 6,000 hours available. Okay, this is the one, step is 3. And let's look at architecture. Within this CPU, they has different architecture, or we call the different partitions or different queue. The first one has 560 nodes. These nodes use the Intel Xeon. This is the code name. This kind of node, SPR, the total has 560 nodes. And each node has 2 CPUs. Each CPU has 56 cores. Okay, this is basically you want to know. So in that way, you can imagine how much nodes I want to use. And then you are going to use this kind of CPU. The memory, you see, the memory is not very big. It's 180. Each core has 1 thread. If your programmer is not really multi-thread, it's only one what they call process. You really don't care how much the cores. They have a large number of the nodes. Okay, you just have the basic idea. Know how many nodes, how many memory, and another architecture, another partition, or another queue. You know, this one is a PVC. This is also a term for the Intel Xeon processor. But we know this kind of computer in this supercomputer system only has 20 nodes, only has 20 computers. If you want to have more number of the computer, you don't want to select this one. But this one has very unique feature is each computer has 4 data center GPU. This GPU is Intel GPU, it's not NVIDIA GPU. But you know, this 20 nodes has 4 GPUs within each computer. And they had bigger memory. You see here, 512 memory. And the core are around the same, right? That is a 56, this is a 48. It's not much difference. The difference is the number of the nodes. But if you want to use STEPy 3 with GPU, you have to select this one. Although only has 20 nodes, but in the another Lone Star 6, they are using 98% utilized. You need to be in the long time. But this one, although has a smaller number of nodes, but this one more available for us. And this is the second architecture in the STEPy 3. This is the third architecture they call the Skylake. It's also Intel Xeon processor. You see, this one has 1060 nodes. This is really big chunk of the machines. Most likely you are going to run the parallel programming. You want to use large number simultaneously to run your job. And then this one, maybe you are looking. You see here, the number of the core is smaller. It's only half. But number of the nodes. And the memory, it's 192. Okay, Skylake, that is a large number of nodes, smaller memory. The fourth one is called Ice Lake, ICX. This is also code name for the Intel Xeon processor. We don't really care how much faster than this compare another. By this 1,000 of the nodes, each node's computation smaller, slower, it really doesn't matter. You probably care how much nodes you have. This is 224 nodes, and also both has 2 CPUs. You see, all computer has 2 CPUs. Just the difference number of the cores. The memory has a little bit different. I forgot to mention about the temp partition. The temp is a system that has a different. Most likely, you are not really know how much you are going to use the temp. Okay, just keep in your mind in case you need consider that parameters. But I think you concentrate on nodes number, memory size, how many cores. That is good enough for you to make this decision which partition you are going to use. Okay, file system. Each individual supercomputer, you use the same login name to log in, but your home directory is in that system. So the step is 3, when you log in, your home directory in that system. If you log into Lone Star, your home directory is in the Lone Star. This is the separate home directory. Each home directory, you have 15. This system, you had 15 gigabyte disk space to save your file. And then you have a workspace that is 1 terabyte. Most likely you want to upload your data into the workspace, or you want to install your own software in the workspace. You just CD, hit return, you're in the home directory. If you type CDW, hit return, you are in the workspace. You see this $sign, that is environment variable. Okay, and also you have scratch space. Scratch space, they have no limitation. No matter how big, you can temporarily save over there. But they are going to purge the space or delete the files. I'm not really sure. They probably every week, or they may sometimes they know the space is the time they're going to purge. So don't rely on the scratch. Scratch is just the scratch. There is no quota. It's very huge. When your access is logged into here, each supercomputer, at least they have 3 login nodes. They are redundant. But login nodes, no matter which login node you log in, your home computer is one place. So sometimes you log in one dot whatever. The home place, when you really want to look at your task, PWD, if you type CDW, hit enter, you are going to get into the work directory. Work directory, you see work 2, this is the code. You see the code is the same, and your username, and this is step 3. And I tested from the Lone Star. If I type CDW, hit enter, the work directory, they are actually the same. Work 2, this is the code name, the project, and my user, and the Lone Star 6. So I can see with underneath my name, step is over there, Lone Star here, I can access both. So you can moving your file from Lone Star to step 3. This is a 1 terabyte. The here has 1 terabyte. I did not test it. There had 1 terabyte. Probably you told it had 2 terabytes. Probably that Scratch is a. I did not test it Scratch if both systems is the same. Okay, this is your file system structure. Lone Star. You see, this machine is very strange, like a box. When they open this box, you see, you see the wire is on top. Whole machine is merged into liquid. It's for cooling. This is the 20 GPU nodes in this box. The rest of the machine is still normal rack air cooling. Look at the Lone Star architecture. Lone Star architecture, they are used AMD CPUs. Step 3 is Intel. Lone Star's AMD. First partition is total have 560 computers, use AMD EPYC processor, and also they has 2 CPUs. Each CPU has 64 cores, and it has more cores, 250 memory, 1 thread for the 1 nodes. This is a temporary location. You see, this is the normal CPU architecture, have 560 nodes. Here, this is the key. This is what actually we are really want to use. A100 GPU. This GPU exactly like this one. They has 84 machines. They have 84 machines equipped with this 1800 GPU. Each machine had 3 NVIDIA A100 GPU. The memory size is 40 gig. If you're running the AI Jupyter Notebook, use the Torch, whatever the parallel computing, you probably need to know when you write program, you need to tell the GPU 0, GPU 1, GPU 2, and then when you write program, you probably need to know that one. Okay, the memory, this is computer memory. This memory is for the only GPU card. The machine memory 256, each one has 2 AMD processor, more powerful. H100, they only has 4 nodes. This is the top line. NVIDIA, most powerful GPU, they called H100. They only have the 4 computers. Each computer has 2 NVIDIA H100. The here is actually 4. This picture I find from some other place. This is the 4. If the machine has 4, this kind of GPU. You see here has socket 0, socket 1, 2 processor, 48. You see here the processor, even this processor is different from the previous one. You see this processor is a 64776. This is a less number of the cores, but they had a higher number of. The here has more memory for the computer, and the file structure. You see here, Lone Star, your home directory only has 10 gigabytes. Your workspace 1 terabyte. The same scratch space, exactly same. You see, the Lone Star, here, the home. This is the same code name. This is the same project name and then username. You see here has work 2, this is Steffi 3, and here work 2, your username, Lone Star. And then if you cd space dot hit return, you're going to see under your name has Steffi 3, Lone Star, and then you can get into the location. This is the place you can move around your files. Scratch space is also available. Okay, we have the big picture. And then we want to know portal, the resources, where you find your information. For example, here has user portal. You can log in. You can find your how many hours, which are available, whatever. And then the rest of here, all this is you do not need to log in. You can, most likely you want to get into the documentation. They have very well documented. Each individual, for example, Lone Steffi 3, you can, the Steffi 3 here, all the documents, what is architecture, how do you use it, majorly, probably you want to reference into this page. Okay, what is resources? Okay, this is place you want to get back to fight whatever you have the problem. Here, probably you are the software available for me. If you are engineer, you want to use very special software. Here have the lists. Most of the, I even don't know what all this about. You see here, the engineer, I know some of you use this ASICs, right? That is your simulation. I know they has MATLAB. MATLAB, even you can, you see the CUDA is here. This is neural network. They tell you what kind of system they are installed. Compiler, GCC compiler, Git, interactive dev. I'm going to talk this one next lecture. Intel, they has Intel compiler. You see mathematics, that is mathematics software. Lamar also has, you see here MATLAB, the license available, MPL. This is the first part. What I'm going to show is here. This is the place. For example, Lone Star 6. This is the page when you log into your portal after you get account. This is place you try to find which one you want to use. For example, they have the development environment. There are the 6 idle nodes, 0 waiting. Okay, you want to use one of these one for you to write program develop. And then you see here GPU 1800. There are total 20, right? Total 20 these kind of nodes, 0 idle running, and you see here waiting for that 39. Here has similar 100 development. That is not really for you to run big job. If you have the smaller job, you want to develop test your program, you can use this one. There's 1 node available, only 2 jobs, none of the waiting. Here had a small, 100 is small. Small means only allow you to allocate 2 machines. They don't want you to allocate 10 or if you only had a small job, you need only 1 machine, you probably use this one also. Idle 8 available, running, so you do not need to wait. This is H. This one is really powerful. since it only has 4 nodes, most likely you need to waiting in the line. Although here says is a 4 job running, probably they have a big job is going to take over. Large, that means there has 460. That is the large partition. Normal. You see, most of people use this normal. Probably they does not really know how to allocate it. If in this case, you really don't need to wait in here to find some other place. Even this large, you does not need that large. You only ask for 2, 4, 5 machine. You do not need to wait in the line. Okay, that is some smaller trick you can find out from here. Okay, rest of time, let's register. Log into here. Log into the, you see here, TACC. Log into here. And then go to user portal. Everyone get into here? Okay, underneath here, create account. Create account. Put your name, the email. You see the email, you must use Lamar email, Lamar official email. They are going to verify. And then you're probably looking for Lamar University. You see, when you type the Lamar, you are going to get here. I cannot click next. You go ahead to click next. What are you?
Username, password.
Username, password, probably you create your own self. Remember your username, password. You see here, if you forget password, you can click that one too. There is the third step. Third step is going to be set up your authentication. Let me log into myself. Whenever you got the account proved, and then you need to follow the procedure to set up the multi-factor authentication. Basically, it's the same as a Lamar. You need to use that Duro to get the access code. You see, make sure you remember this place. Go to the documentation. On top here has multi-factor authentication and setting up for your account for the multi-factor. After you log into here, after you log in, this is your username. You need to go to manage account. Manage account. Manage account. You see here has the picture. So your username, manage account, and then you need to pair device. Basically, documentation is here, and then you can, after you log in, go to your username, underneath there, click manage account, and then pairline your phone. The phone is same as you already installed that Doro. The Lamar use that one. Create a barcode, and then scan your barcode. And then when you look at your Doro, you're going to have this passcode. The passcode initially is dark. You have to click this show to show the number, and then put into your TACC account, activate. Okay, that's all. Thank you very much.